Hi everyone, it's Coach Fred again. Today I'm going over, this is like video number 3 of the functions, the tangent function. So y equals tan of x. So I brought back the chart that we have for the quadrantal angles. And remember, we're graphing our functions, our trig functions, using the quadrantals. It just makes it easy for us. Now, the tangent function is different. If we really look at the chart between sine and cosine, we get 1, 0, 1, 0, 1, 0. We're oscillating between 1 and 0 and -1. Tangent's different because we remember tangent is sine over cosine, and we remember that that means there's going to be undefined values. So if you remember from our work in previous units, when we get these undefined values in a graph on a function, we tend to have something called an asymptote. So that means that if we look at this graph and we still get in our 4 equal parts on the x-axis, right, representing the 4 quadrants of the unit circle, and we label those quadrantals. Let me go ahead and do that. Then the next thing that I always suggest we do is we put in our asymptotes. So there's going to be an asymptote anywhere the tangent function is undefined. Okay, so I'm going to put in an asymptote. That means at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. So that means already that you can tell we're going to have a domain that's not all real numbers, okay? All right, so then if we plot all our zeros, we actually don't get much of a graph. Here, let me do blue. Let me do green, actually, right? Because we only have these zeros. So if we consider some of the other points on the graph, I like to think of pi over 4 because I know that tangent at pi over 4, and therefore at negative pi over 4, is going to be 1 and -1. All right, now I could plot more points, but I want us to remember that tangent of like pi over 6 is root 3 over 3, and tangent of pi over 3 is root 3, so it's growing. So, like there's a point maybe like right here and right here on the graph. So the graph actually looks like something like this. Well, that's not so great, but you get my point. So it looks actually almost like the cubic graph. Right? It's getting real close to those asymptotes, but it's not going to actually ever touch them. So it looks something like that. All right, so let's talk through this domain. So because this graph goes on forever and ever, when we're talking about the domain of the function, we have to recognize that it doesn't exist at every single pi over 2. And the distance from pi over 2 to 3 pi over 2 is a distance of pi. So what we can say is all x, so all real numbers, x cannot equal pi over 2 plus pi n. That means I keep adding pi. N is the number of times I add pi. And that means there will be an asymptote every pi from pi over 2, both in the negative and the positive direction. The range, hopefully you're already seeing it, is actually all real numbers because it's going to hit every y coordinate on the axis. Now, let's look at the period, okay? Let's really think about this. If you think about the distance from negative pi over 2 to pi over 2, that's not 2 pi. That's just pi. Or from pi over 2 to 3 pi over 2, that's again just pi. So my period of tangent is different. It's pi. Oh, and there's that word amplitude. Remember, amplitude is half the distance between the max and the min. So if this graph is going off forever, it doesn't have a max and a min, so therefore it doesn't have an amplitude. Okay? All right, guys, so that is the tangent function. Hopefully that was fun. Have a great day.